Okay, in this video next we are looking at the function called rate, or if you were using the calculator, this is the variable same as I by y. On the third row of your calculator, if you're using the formula, basically it is R that we have been using in the class. So it's asking, you're looking for investment that will pay 1200. If you invest 1000 today, what is the rate of interest for 5 years? So again, starting with the function, it's called rate, and as I showed in the previous video, you can find that function, but I know it already, so it's rate, R-A-T-E, and then again when you start the parentheses, it will ask you to input different values. First it is asking for NPER, number of periods, so that's 5. Then it is asking payment, so that's referring to the regular payment that you have every period. We don't have anything in this example, so skip that. Present value, so we are investing $1000 today, so 1000 is going out of my pocket, so that's negative 1000. And then we are receiving 1200 in future, so the future value is $1200 positive. And then again end the parentheses, and it will give us the interest rate of 4%. And if I want to look at more values or points after decimal, so it's basically 3.71% interest rate. Next we have is number of periods. So solving for n, how long does it take? Those kind of questions. So here the function that we have in Excel is called NPER. So that is number of periods. And again, this is saying what is the interest rate. So here we are willing to pay 20,000 for the car, and we have 15,000 right now. So our goal is to make that 15 to $20,000, and the interest rate is 10%. So how long will it take? So the interest rate is 10.10. There is no payment again. We are investing $15,000 that we have, and our goal is to make it $20,000. That's what we want back in the future, so that's positive. And the parentheses, and that will give you the number of periods, and it is 3.02 years. Okay, so again, very quickly, just let me show you. When you click on the formula, it highlights what values do you have to enter right below. So first enter rate, then payment, then present value, and then future value. If any point you forget what that is, you just click on the FX, and it will bring you to the screen where you can read that FV is a future value or a cash balance you want to attain after the last payment is made, and so on. So that's sort of your cheat sheet that you can find out what each of those input values are asking for. So that is number of period. So this is all the sort of examples that we worked on chapter 5, where we had only one cash flow at the end of the time, whatever those number of years or months were. And then we switched to annuity, where we have the same payment at a regular interval for a specified number of periods. That's the definition of annuity. So then we say, okay, how do we calculate the present value and future value, and n and all those things for the annuities. So here, first example, we have, let's say that you can pay $632 per month as an installment for the car loan, and the interest rate is 1% per month. How much can we borrow? So we will take the loan today, and then we will pay $632 every month for 48 months. So how much loan can we take? How much can we borrow? So the goal is to find the present value again. This is the same present value function that we saw in the previous video, but again, the one thing difference here is that now instead of a future value, we have a payment. So for example, again, you write equals present value, start the parentheses, and then it will ask you what is the interest rate, which is 0.01. Number of periods, 48 months. So again, make sure that we are matching the rate to the period frequency. So since we are using number of months, we are going to make monthly payments. We need to use the rate in number of what is the rate per month. So if the annual rate was given, we would have divided by 12, but this is already the monthly rate, so we just use that as it is. payment, we will be paying $632 every month, so negative $632 going out of my pocket. And we don't want to make any additional payment in the end. We don't want to have like a balloon payment, for example, and we don't want to make any or withdraw anything back, basically. So there is no future value, so we just stop the, you could say e comma 0, or you could just stop the parentheses here and then enter, and it will give you the present value. So about $24,000, if you round it off, is the present value. So you can buy a car that is worth $24,000, and then you can pay $632 every month to towards that loan, and that will cover it within 48 months. So that is the present value of annuity. Then we have future value of annuity. So suppose again you begin saving for your retirement by depositing $2,000 per year. So you're going to deposit right now when you're working, and then after you retire, let's say in 40 years, how much at the time of the retirement, how much money you will have if the interest rate is 7.5%. So since we are saving every month same amount, or every year in this case, so that's the payment, and then our goal is to find out the future value. So this is also same as the future value function that we saw in the first video. So equals future value, and then we have the interest rate, that is 0.075. Then number of periods is 40 years and PER. Then it is asking us for the payment, and we are going to deposit $2,000. So $2,000 is going out of my pocket every year. And then present value, let's say if I already had deposited $5,000, that would go here, but we don't have anything already in the account or anything like that. So either we can make it 0, or we can just leave it out and just say enter, and that will give you the future value of this annuity, which is about $500,000. Okay. The next we have is the payment. So suppose you want to borrow $20,000, you can borrow at 8% per year compounded monthly. And if you take a 4-year loan, what is your monthly payment? So we are trying to find out the payment. Again, we have a present value because we are taking $20,000 right now, or we are buying a car that is worth $20,000. And the interest rate that the financing company will charge us is 8% per year, but with monthly compounding. So equal to payment is what we are solving. Then we have the interest rate of 0.08, but that is for the whole year. So remember, we need the rate for the month. So that is 0.08 divided by 12. Number of periods, again, we have 4 years, but there are 12 months in every year. So that's times 12. And then present value is $20,000, or something worth $20,000 is coming in my pocket right now. So that's a positive value that we are receiving, and enter, and we will be paying $488.26 every month towards this car and car loan, and that we'll be able to pay in 4 years then. So that is your payment.